Hey, I hope this always happens. Um, nice. Here. So, hey, welcome to this Global Hack Week, Cloud Week. And I'm focusing today on something that I really like. Some of you don't know, but I'm a mechatronics engineering student. So, one of the small parts of the whole major the career, it's just software. The other three parts are electrical, mechanical, and control. So a lot of circuits, a lot of hardware in there. Um, but I'm being rude. So just let me introduce myself for those one who are new. My name is Alberto, and I'm your mainly hacking coach from Mexico. So in this session, we are going to start exploring the wonders of the hardware world. Right? Um, I'm going to show you some basic circuits. We're going to take the code, as I mentioned in the Discord message, to the next step, which is taking it to the real world, right? Um, Actually, this is one of my favorite parts. We will be discovering together because this will be my first time doing this specific configuration during the session. But the main idea is that at the end, you get the chance to start implementing hardware in your next hackathons or your next projects, right? Because there's a lot of fun and there's a lot of amazing things you can do with hardware, right? If the there are endless possibilities with software, now can imagine with hardware what you can do. So yeah, let's start from the beginning. Um, I will start sharing my screen on the documentations and stuff, and I will also be switching to my phone camera so I can show you the setup that I have currently right now. Um, but I want to tell you this again. One of the parts of my career, one of the biggest parts, it's circuits, and I always tell this story, and when people ask me why to choose software or why do you choose yeah, coding as a way of living, because I'm a programmer in my day to day. I'm front end developer, um, but it's again just a small part of what I'm studying. Even though when I was in what will be the translation, high school. Yeah, I think high school will be the proper level here in Mexico. When I was in high school, I was in a technical school, so I had to choose like a technical career. I wanted circuits and all that had to do with electronics, um, because I like that since middle school. I attended classes in middle school for that. Even younger than that, I have to admit that all my life I'll be attached to engineering things, but yeah, mainly for circuits and stuff, right? Um, but then I realized that was not the most interesting part, or not something that keep me awake in the nights, right? So I then choose. Well, I had two options: software, like directly. There was a career to studying like technical programming and stuff, and more like mechanics. And I choose mechanics because I had this idea. Okay, no one is going to give me information on internet on how to use an industry machine, like a drill, like CNC, like the machines, right? The hardware stuff, like the real heavy machines. And do this on myself will be harder than just learning how to program, right? learning how to program, just you require a computer. So I choose mechanics. Um, and I think I was right. I mean, at some point, I realized, like, okay, if you think, in this case, me, if I think that only a computer is needed for learning how to program, then let's start learning how to program, right? And you're probably doing the same because you're here, you're trying to learn some things new. So uh, I'm telling all this story just to say, um, there are a few initiatives, a few courses, sessions, and stuff like that, and that wants you to teach you those extra skills that are really really good. So in my case, I choose the hardware path in real life, like studying in person, because I thought it was harder to learn them online, and I choose to study programming online because I knew it was easier, right? In this case, I want to turn the things as they are, and I want you to teach. I want to teach you, sorry, the abilities of hardware, and that's it, right? So, with that said, before you start doing an IoT project, I will recommend you to do a lot of research, depending on your circuit's ability, on your hardware ability. And what I mean here is that, for example, there are plenty alternatives for electronics, for IoT projects. You have Arduino, you have Raspberry Pi, for example. You have, um, what's the name of this? FPGAs. Yeah, yeah, FPGAs. You probably haven't heard of this before. Even more of this because this it's made by a Mexican company called Intesc. But this type of computing, it's called FPGA. The regular computers are called ASICs. That's different in the matter of, with these ones you don't have specific architecture. These one you have to program the transistor. So you're programming a hardware with these, with languages like VHDL or Verilog. I only know those two, but yeah, you have to program the how the transistors are connected here, and that's very interesting. But I have to admit, this one it's hard. It took me a lot to, I won't say master because I'm not a master in this, but it took me a lot just to comprehend what these do. I have friends right now working in developing this kind of stuff, and I think they are geniuses. I have to admit. This one has an Xilinx Spartan 6. Just if you want to check it out later. And for example, and a Raspberry Pi, it's a computer. It's fully a computer. There are other alternatives. There are Libre boards, for example, which is other hardware for that. And same as this one I have here. This one, it's not an Arduino, but it's a Node MCU, which is an open source alternative to the expressive ISP32. And same as Arduino, it is a microcontroller, right? So in this case, we can picture two level of hardware: microcontrollers and microprocessors, right? So in you, if you have a microcontroller, you probably will be allowed to do um, things like digital inputs, digital outputs, analog read, analog output, or PWM, depending on which board you have, connecting through Wi-Fi, connecting through Bluetooth. For example, Arduinos in the base, the Arduino one doesn't have that type of connection, right? So I will say this one, for example, it's more powerful. But then you have others like the Pi Zero, which is a board from a Raspberry Pi company, but it is not a computer. It's the only one they have that it is a microprocessor, right? So let's make the difference there. And I'm telling you this because for some cases, some hardware will be like an overkill. You know, uh, you don't have or you don't need to have a Raspberry Pi, which is again a full computer, just to do analog read and digital outputs, right? Uh, if you are using a Raspberry Pi, that's because you are using something heavier or something that requires processing, right? If you're just reading signals and then sending them out to your computer, for example, there you're using a microcontroller, and the microprocessor is in your computer, right? Um, and well, I'm currently working in a project. Actually, it's my thesis project, and I'm using a Raspberry Pi to do like the control of DC motor, and reading some microphones, and I'm reproducing music over a speaker. I can later tell you what I am doing my thesis about. But the thing is that I require processing and I require the Raspberry Pi. So in that case, it's kind of justified, you know. Um, in this case, and for IoT in general, in most cases, that's the opposite. You will require the less amount of electronical power just to read signals from the real world, right? Um, there are even other boards. Actually, I have one of those right here. Um, this one it's from Arduino, and it's from a series called Maker, and this is a one 1300. Um, this one is for connecting with WLAN protocol WLAN. It's a long distance range protocol that allows you to communicate over really low consumption of energy. So in the in the field, one of those can help you a lot to save energy and also can help you to establish connection over kilometers because for example, if you leave the room, Bluetooth stops working, right? So Bluetooth might not be the solution for you if you want to do something in the field, like in a cornfield, or I don't know, in avocado field, right? Um, Again, it will depend a lot on the project you're working on. Same as if I tell you so in software, right? So you can relate more. In some cases, you will do REST. In some cases, you will do Graph. In some cases, you will use non-relational database. In some others you will, and so on and so on. Same as you have to know your stuff in software, same you have to know your stuff in hardware. In this case, we are going to create just a simple project with this board because I think, well, no, I don't think. This is one of the ones we give in the Meoli hacking when we have the hardware lab. I seen them. Um, and I think it's getting pretty much community around this. So join me now to start learning about this. Let me start sharing my screen. You will see a blip because when I change camera, I cannot use the phone camera and my laptop camera. I don't know why, but don't worry, you will see. Okay, it looks like you can look both here. Okay, amazing. So um, here you. I'm adding this to the stage, and okay. I'm sorry if this is not focusing. Okay, I'll try to do my best. This is with my hand. Let me clean the camera. Sorry. Okay. Uh, I think. Oh, maybe if I lock the screen. Okay. Well, um, now this can focus. I will show you how this is connected. It's really simple. Here, this it's the power cord. This one it's just a simple USB-C cable that goes through my computer. I'm using an adapter because the cable I had it was just USB-A to USB-C. If you have a USB-C to USB-C to your computer or something to connect directly, there's no problem. Don't you worry about this. The next one we have here, we can see clearly in a minute. Okay, okay, it's focusing. Okay, I think it looks clear now. Here we have the 3.3 voltage output. Here is the ground output. So if you're not familiar with circuits, circuits need to be closed loops, right? So closed loops starts with an power output and ends with ground. So in this case, for example, this it's going all the red line. So where you see in all these row, these are going to be 3.3 voltages. And in the blue one, I'm taking the output of the ground from here, which is the same here, 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 and here. So we have four. It's hard. Sorry. We have four ground outputs, and I just needed to connect one to this blue line here. So we have 3.3 here, ground here, same as in here, and that's it. This program or this one, it's programmed now with a blip example, so they change times here, and these other two, they are not connected currently to any any GPIOs, which means general purpose input outputs. This is just connected directly to the voltage and the ground. So same, think of the closed loop. I connected these ones here just for you to understand it better, but we have the 3.3 volts here. We feed it to the button, then the button it's stopping the flow. There's this great analogy I think all teachers in electronics uses, that you can think of electricity on the way it behaves as water. So um, think it's pipes, right? So we connect the water source here through this pipe to this think of the grip. Just so if you close the grip, there's no water flowing, right? Let's open it, and then water starts flowing. Same with the other. Same, the other it's connectly exactly the same. If we change it to here, in this case, oh well, then don't worry, it's just connected directly. Yeah, it works here. So um, I thought these were a different type of buttons, but There are ones that has normally open and others that have normally closed, and if you change them, you change like the behavior, right? In this case, it doesn't, or at least, well, we can let's focus on that. So with this simple connection, I already show you how this looks like. So if you want, take a screenshot of this. Actually, I'm going to take one myself. Give me a second. Because we probably are going to use this mental image later. Okay, perfect. Now we have it. And before I um, close this camera, I wanted to show you this other one. This one here, it's the Raspberry Pi I was telling you about. I'm using this mini computer. Actually, these ones were the first with IRM that I knew. Even before Mac uses that architecture, Raspberry Pi used that. And it's connected to a power source. The power source feeds the DC motor right here. This metal box, it's a driver for the DC motor, some wiring and stuff, and well, that's it for the personal project. Uh, this one is the other one I was showing to you, the Amoeba. So this same can be programmed as a computer, but in difference to the Raspberry, which is an ASIC, these FPGAs have to be programmed uh, from zero. Like you have to program the architecture of everything, the transistors, the whole stuff. So uh, these are really cool. Um, but again, this is a more advanced level. The other one I was showing to you is this Arduino board, but this Arduino, it's different in that it doesn't have a Wi-Fi connection or everything. It connects through one, right? Um, we can normally find specifications and stuff for the boards in the back part. So here we have more information about it. You see? Nice. So let's keep moving. And well, here I have some peripheral. This is a LED module we can use. We are going to have some readings from this potentiometer, from this sensor. I can't remember the name of this actually, but what this does is that it can help you measure distance. And we are going to use an OLED matrix off to show off some outputs here. Some cables, some LEDs, some more LEDs, some handy small cables, and that will be it. Okay, let me return to the previous configuration. Nice. Hi. Switch bash. Hi. Um, so let's return. What else? What else? What else? I have another thing I wanted to show. Okay, now let's continue and let's start exploring these other. So I can stop the sharing and give me a second so I can get to the node. Okay, perfect. Let me start sharing my screen again. I'm going to allow that. And this screen. Okay. Um, Full screening here. And well, now we can focus on this fully. Uh, huh. Node MCU firmware. This is the one we needed. This is from the Node MCU community. I can share with you the link. Here it is. And also, taking advantage that I am sharing the link right now, I always forgot to share the check-in link. So here you have it. Thanks a lot, and please don't forget to check into this section. And well, let's move to now the MCU page. They have the flasher, the dev kit, some other util repos, right? So let's check the docs. Lua based interactive firmware for ISP 8266, 8285, and just ISP 32. Um, let's open this page, but also let's move to the documentation here. Node NCU 3.0, Lua based firmware for the SOC. Node MCU, it's an open source Lua based firmware for these and uses on module flash based SPIF system. It's implemented on C and it's layered on the expressive non OS SDK. Firmware available with or without floating point support. Um, okay, let's read now here on the documentations. We can close this now. Okay, this is what we wanted, the documentations. The Node MCU release and dev targets, blah blah blah. The programming model, Lua Flash Store was introduced, allows Lua code in its associated constant data to be executed directly out of flash memory, just as the firmware itself is executed, releases up to date, blah. But what we want is getting started. The basic project to get started with an MCU consists of the following steps. We have to build the firmware. Have to flash it to the board. When what we mean with flash it, it's to upload the code we built from the previous steps, probably with an hex file to the microcontroller, right? Um, that's upload the code, right? You typically do step one and two only once, but then repeat steps three as you develop your application. If your application outgrows the limit on chip RAM, then you can use Lua Flash Store to move your Lua code into the flash memory, freeing not freeing a lot of RAM for available data. This is why this is a good idea to enable S for step one, if you're developing for like your applications, as document below there, it's a different approach. Okay, task and OS selector. For each of the tasks, you have number of choices with regards to tooling and depending on the iOS you are. The color boxes represent an opinionated path to start your journey, the quickest way to success to speak. Feel free to follow the links above to get more detailed information. Phew. Cloud Builder or Docker. Okay, opinionated says Cloud Builder. Let's open that. Flash to firmware, Node MCU, PyFlasher, except for Linux. I don't know why, but again, let's get to opinionated. Upload the code with NumCU tool in Node.js. Love it. Love it more than Java. How to read this? Okay, we're missing more. Oh no. Upload ls images with generic, compile, boot Lua, build ls. Okay, yeah. Uh, just if we want LFS. In this case, we are going to skip it for the moment. How to read this use case? You're just starting with the Node MCU, and your OS its choice. No. Then the boxes in the Windows column are your guideline. Okay, build the firmware on the Cloud Builder, which is this one supposedly. Okay, it's taking a lot of time to load, uh, but yeah. Build the firmware on the Cloud Builder, download and run the Node MCU by Flasher to transfer. Okay, download an AS Explorer, which requires Java, blah blah blah. Okay, in Cloud Builder, already opened this, so we can close this that we have here. The Cloud Builder allows to pick Node MCU branch, modules, and a few other configurations options. After you build it's complete, you will receive an email with two links to download your custom firmware. One for Node MCU with floating support, and one for Node MCU without floating support. So let's do that. Node MCU custom builds your customized Node MCU firmware, and we build it just for you on the spot. Interesting. There are no builds today. Interesting. Uh, okay, my email it's over to at camarena.me. Or make sure you can receive build data notifications. Uh-huh. In this case, I don't want to subscribe here. Select a branch, release. Okay, which one we should use? That's an interesting one. We recommend using the floating point, even though the integer values uses less RAM for storing variables. As there is little runtime difference between the two variants. Furthermore, the floating point variant handles no interface value properties. Uh, okay, well, then release. Latest release, why not? Models to include file, GPIO, net, node. Okay, we're going to use PWM, timer, ward, Wi-Fi. We're going to use WebSocket probably. ADC, I'm not sure. HTTP, net node, blah, 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 so forth. Well, I think with this, we're good to go. Um, yeah, let's add the ADC and the ADS. Just yeah, just in case. Miscellaneous options, DLS, SSL support for provided includes the book on, turn it on only if you're troubleshooting and developers. It will increase the size of firmware and decrease its performance. Okay, for right now. FATFS from reading from SD cards for ISP32, you need to enable the SDMC module. No, right now we are not. Okay, nice. Then start the build. Strike. You're successfully commissioned an MCU custom build for the release branch. You select these following 12 models. Nice. Payback time. The next door, would you buy me a beer? Yeah, try to donate whenever you can. Uh, uh, okay, perfect. Perfect, perfect. Let's return, and I'm waiting for the mail. In the meantime, we can continue to the next steps. I will open my mail just to see if I haven't received it yet. Okay, I think I received it now. Yeah, perfect. Give me a second, I will download it immediately. Okay, it's kind of slow, but it's downloading. So while it downloads, let me make sure I just download the correct one. Floating point build. Okay, yeah, nice. Oh no, this just said that my custom build it's running now. While we wait, we can subscribe to the newsletter. Not for the moment. Let's continue with the next step. In the meantime, Node MCU PyFlasher, self-contained Node MCU Flasher with a queue based on Python, estpool.py, see below, and WX Python. A runnable exe is available for Windows and an DMG for Mac. Not installation required on Windows and Mac. Instructions on how to run it Please order available, blah blah blah. So this is the same page, I'm guessing, so we can close it. We can also close this one since the build is already in progress. Actually, I just received a mail. Let me refresh to see. Okay, build finished. Now it finished. It's a great thing they notify you that your um build it's on progress. I think because some cases I can imagine it takes longer. Um, Having the question that, oh, my one will be running. It's great. It's great. It's great. Um, Let me return, and now again make sure floating point. So I download the binary. Yeah, I downloaded by Flasher. Also the mail contains the PyFlasher link, but I think we will follow the one here in Docs. Let's see if this is the one. Insert drivers for USB to serial. Which driver you need depends on the ISP32X266 model or the USB to serial converter you use. Uh, Connect the USB cable to the base of the computer. Download the PyFlasher. Let's download it. Well, it these two are the same, I think. Yeah. So these have finished download. Sorry, to load. Click the release section for downloads for your platform. For every release, there's at least an X for Windows. Starting from D, there's also a DMG for Mac. Okay, release section. And I'm downloading this DMG. Nice. So once we have it, install the drivers. Um, I'm not sure if I already installed them here. Um, I will guess that it is, but if anything, that will be on my first step on the list to do the book problems. Um, ESP2 Pi was started as ESP8266 community effort, but it has since been adopted by Expressive. It's their official recommended way to flash ISP chips. But with this one, this is a self-contained one, so no need to do this. This will be not graphical approach, which I will respect more. But since we're short of time, I probably will take a look to this later. For the moment, let's keep with the other one. Explore to be defined. Node MCU tool. Arguably, Node MCU tool, which requires Node.js, is the better code upload e execution tool than eExplorer. Okay. Also, in contrast to the former, it is very well maintained. We also understand that Windows users in general prefer UI over command line. Yeah. uh, the list of features it's quite long, but it's essentially Node.com tool offers upload with Lua files from the host system to the device, manage the device system file, delete up, download, etc. Run files on Node MCU and display the output over Word or Serial. Okay, quick start. Install Node.js and npm. If not available, yeah, I have them. So npm install this globally. Nice. Let's do that. I haven't done so. Hyper. Okay, I'd probably be better to close some of these since they are seriously putting down the performance of the computer, right? So now let's wait until my terminal finishes. Come on, I copy and paste it. Wait, it's not downloading. Okay, npm install node, and I'm going to add sudo because this is a global one. And let's wait until the install is done. Um, okay, let's make that run. We can then now verify that this is installed, checking the version. Once this is done, how big is the installation? I'm not sure. Good question though. Node and we can check that. I mean, if it's npm. But if you're worried about the size, I don't have as much space available in my computer too, so you won't need to worry. In general, node packages aren't that big. 37 files, and the impact size is of 83.2 kilobytes. Yeah, not that big. Um, nice, great question. So packages added. Let's check if installation work succeed. Version 3.2.1. Lol, thank you. No worries. Um, upload the Lua file. Well, I don't have a Lua file this far, so probably that will be a good thing to start with. Then run, upload, and run. Um, Okay, interesting. I think we're missing the point where we upload the binary file, release flash. Am I missing something here? Oh yeah, I forgot. We we downloaded the PyFlasher, of course. Okay, just let me finish reading with this. And now, Cloud Builder, Flasher. compile. If I step here, you'll find the same information with. Okay, this is important. Huh. Below you find necessary information flash node MCU firmware file. But since I think the one I have already comes with firmware, I'm not sure I want to. Okay, yeah, and now think of it. It's helpful if you want to update your firmware, but since I don't think I'll be updating my firmware, I'll just stick with the one I have. I don't think flashing these will be a great idea. Upgrading firmware, yeah, yeah, that's a good question. So first, I will try to upload code directly without having to flash it. Uh, so let's start with some examples. There was a page I wanted to show you too. Actually, it's not hard to remember. I think it was nodemcu.com www, because for a reason, if you don't put the www, it doesn't happen. Um, let's wait. And here they have some examples. Oh my god, English. Connecting easy and open source framework and development kit that helps you prototype IoT products within a few Lua scripts lines. So, examples: connect to a wireless network. We are going to use this one to read from an input and take that to an output, right? Directly as that. So, installer, okay, this was already downloaded. This getting started, we can close that. We check the size of installation, tool summary, compatibility, frequently asked comment, blah 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 requirements. Um, yeah, let's check. Node MCU 2 init Lua. You will see Lua cannot be opened. Uh, init.lua print the serial console when the device boots after it's been fresh refreshed. If Node MCU finds an init Lua, init do reboots. Blah, blah, blah. Okay, I think this doesn't concerns us. Okay, compiling Lua on your PC for uploading. If you install Lua on your development PC or laptop, then you can use standard Lua environment to develop application PC applications and also use standard Lua compiler to syntax check any Lua source code. However, because of the architectural differences between the ISP chipsets, which blah blah blah, the system API are different, and the binary output from the standard PC Lua cannot be run on ISP32. To address this issue, the standard Node MCU make now generates a host executable lua.cross or lua.cross init for integer builds, as well as the firmware binary itself, compiling source on the platform for use to another. It's known as cross compilation, and it's this lua.cross compiler allows you to compile Lua source files on your PC download into ISPC binary format. Also includes okay. This is kind of messed up. I didn't understand that fully, so I'm guessing compile code, uploading code, support reference, facts, white papers, Lua models, C models. I would prefer, I don't know, maybe C. Uh, uh, but okay, let's go to compile code section fully. Visit whilst the Lua virtual machine can compile Lua source dynamically, and this can prove very flexible during development. You will lose less RAM if you compile your source before execution. Compile Lua on your PC for uploading. Um, if this just helps, like reducing RAM consumption, then I not need it right now because, um, well, at the moment we can do it since this will be a very short program. Programming model. Node.mcu programming model similar to Node.js, only in Lua. It is asynchronous and event-driven. Many functions therefore have parameters for callback functions to give you an idea of what node-singing program look like. You can study the short snippets below. For more extensive examples, you have to look at the Lua examples. They're in our GitHub repository. Yeah, this one's the one I wanted. Actually, it's the one I copied, right? Um, okay, I already have Hyper open, so we're going to move to develop L2 Global Hack Week Cloud, and here to um, oh no, yeah, um, code IoT 25. Um, it will open in a second. I hope so. Yeah, I was planning to do some slides for this, but I'm not sure right now. Um, so yeah, maybe its slides are not needed. Let's io.lua. Yeah, nice. I like that. Udon will be equal to 1. And LED will be equal to 2. GPIO output needs an input. GPIO LED it's an output. And I want to know what they're doing here. I don't want the low, I want the. Okay, let's let's read some docs because I'm not sure what I'm doing there. Uh, yeah, I'll open the examples just to see. MQTT. No, more simple examples. Come on. My file. So, okay, let me move myself from there because I'm blocking me. Um, web, TCP, pipe utils, make phone call. Wow. ADC to RGB. No, I really want a simple one. Uh, what's DCC? I don't know. Simple example for responding to MRAD. What? Um, okay. Email, Lua, MQTT, PC, time zone, gossip, pipeline. Okay, these are terrible examples. I just want one that helps me do that. Connect to Wi-Fi access point, register event callbacks for Wi-Fi events, manipulate hardware like Arduino. Okay, write high. So this writes high, but I want to read. Maybe like that. I'm not sure if something like this will work. Like read the button for this. I'm sure. Um, okay. Let's do the getting started. Okay, let's check this build Luacross. A local copy of Lua Cross is only needed if you want to compile the Lua files into an LFS image yourself and you're not using Docker. But I don't want to compile an LFS image myself. Um, so then what? What should I do? References, language reference manual, programming node MCU. Okay, this cool works. Developers using the Node MCU environment should familiarize themselves with 5.3 LRM. Lua reference manual 5.3. Okay, let's open that. The NRM supplement the LRM. Who chooses these names? Content and model documentation by focusing on complete description of the difference between Node MCU Lua and the standard Lua. It adopts the same structure and styles as LRM as Node MCU provides a full implementation of the Lua offers. Of, uh, basic concepts. The Node MCU runtimes offers a full implementation of the LRM2 core concept with the following adjustments: values and types, C models, garbage collection, coroutines, well, language. The Node MCU runtimes offers a full implementation of the Lua language as defined in these thing. Okay, Lua.5 reference manual. Introduction. Lua is a powerful, efficient, lightweight, embeddable scripting language. It supports procedural programming, object-oriented programming, functional programming, and data-driven programming. Data description combines simple procedural syntax with powerful data description, implemented as a library, writing in clean C, the common subset of standard C and C++. Basic concept, values and types, environment and the global environment, error handling, metabolism and meta methods, garbage collection maintenance, weak tables, routines, the language, lexical conventions, variable statements, chunks, assignments. Well, I will return to the contents, basic concepts, the language, lexical expressions, arithmetic operations, the application program interface, the stack size, error handling, some libraries, functions, types, load time. Okay, well, yeah, but it's not means anything to me here. Um, the standard Lua runtime supports both Lua models that can be refined Lua functions. Yeah, GPIOs. Node MC2. Pin 2, it's GPIO 04. Who chooses that? Mm, well, I also need the pinout actually. Now that I am into this. Let's look. Random net tutorials. Okay. I think this is the one we have. Just let me make sure. This GPIO4. Okay. Yeah, I think this is the one. So here. Do you have to prepare your system to match for requirements, especially as beginner? You should read this particular careful, no CCL driver. Depending on your model type, you have to install the platform specific terminal, blah blah blah. Okay, they insist a lot with this. They currently there is currently edition with Node 11 on Windows 10 platforms. Okay, this was old, I think. The location of the binary file. After installing, you should open new terminal windows and check if tool is working by obtaining the version. For local installation, that means you have not installed that in global. Identify your Node MCU device. Now you can connect the MCU model to your computer. The model will be accessible via a virtual serial port. You can identify the port by using devices. Okay, this is interesting. Um, let's see if mine it's there. Devices. It's that like this. MCU connected devices. Yeah, one. Well, Silicon Labs, USB-C Silicon Labs. I don't know. I have my phone connected. Let me just unblock it and watch again if that's not the one that was being recognized. Um, okay, yeah. Okay, still the same. Nice, one device. Just to make sure, I will unplug it, run this again, and this should be zero. Now I can plug it again, and this one. Perfect. So at least it recognized the device. Just I need to make a file that works. And doing that, apparently, it's not that easy. This model provides access to the GPO purpose, general purpose input output system. All access its based on the IO index number on the node MCU dev kits. It's not an internal GPIO pin. For example, the D0, it's on the dev kit, it's mapped to the internal GPO pin 16. This is uh, this. So, for example, D0, it's GPO 16. So, what they want to say here is that they does not correspond. So, 2, it's GPO 0. It's the one that they mentioned here. So for us, button will be 1. That means it's GPO 5. And in the pinout, that translates to D1. So let me make the right connections. Now we know that. Now that we know this, I think it will be easier. But hey, I always think I'm not sure. D0, we said? No, D1. Okay. Um, so I'm making the connections. Don't think I am leaving. Give me a second, and now we finish them. I'm trying to make this as smooth as possible. Okay. So the output, I want them to be 5 and 4, which is, well, no, I want them to be GPOs 15 and 13, which is our D8. D, I will change it to 6. D6. So making the correct changes on the file. The inputs of this will then be GPIOs 9 and 10, and that is these the next one next to the rest observations. Okay, connections are down here, so let's change. Remember, for GPIOs 10 and 9, it was 11 and 12. So I'm going to add another button 2. I'll say 10 and 9, right? 10 and 9, 11 and 12. And I'll add 2. And I have these on GPIO uh, D6, which is 12 of 15. 12, it's 6, and 15 is 8. Okay, we are making progresses here. So 16 can be used as GPIO road, not support for open drain, blah blah blah. GPIO mode, initialize the pin GPIO, set the pin in output direction, output seed also read and write. Yeah, GPIO read the values, see mode. So I think that will example. Okay, yeah, great. Mode. The one is going to do an output with pull-up configuration. So out. What's that? Serial 1 byte. Okay, that's weird. Serial 2 allows output based on a sequence of delay time in microseconds. After each delay, the pin is toggle. Okay, well, that's interesting. Let's go to the right. Set pin and set it to pin high. Okay, so I'm guessing this is not the one we wanted, and I'm going to ask Copilot read values from the buttons and write the reading on the let's as output. Okay, so let's see. Mode buttons to our inputs and let's our outputs. Then it says something TMR alarm, TMR alarm out button state. It's read from this and write from that. So I just need to verify what is this. TMR sounds like timer. uh, TMR, yeah, here. Timer model, yeah, of course. Timer model allows access to simple timers. Okay, what we're doing here it's an alarm. Um, so TM create TM alarm. We don't have to TM create TM alarm. This is a convenience function combining register and start into a single cell. This is the reason why the method has the same parameters and it's invoked on an already running timer. The timer is stopped, new alarm parameter set. Example. I think this is not the support 0100 TM alarm auto function and okay, well, we have this. Let's try that. How we are supposed to upload this? For local, identify, create, upload a new file. Devices, port def tty USB 0, date tty dot USB serial 0001. Hello world Lua. No. IO Lua. Upload. Oh yeah. um, the comment I'm missing it's Node MCU. Node MCU tool. When able to establish connection, timeout its node response. It's online and on Lua. It's Node MCU online and the Lua interpreter ready. Um, let's debug. Okay, here on the documentations we used to have another thing, another set of instructions for uploading the project here. Um, uploading code. Serial interface output time. As with the flashing, there are several ways to upload code from your computers to the device. The Node MCU transfer uses blah 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 to change the speed after boots. If the device panics at reset, errors will be written tools transfer applications to code. It's essentially task ones that you will perform quite frequently. Hence, you don't make sense try a few different uploading tools until you find one that feels comfortable with. It's almost a dozen classical uploaders in addition to IDEs or IDE-like application, which of course transfer code as well. The non-MCU firmware does not give any recommendations as for you which uploader to use, nor are the non-MCU approved tools. The below list are just three in a particular order. Okay, we are not using any of these. We're using this. You will see Lua cannot open init Lua printed on the serial console when the device boots after it's been firstly flashed. Uh, Unable to establish connection. No, this is not the. Do I need to put it in flash mode or something like that? I remember. I'm hitting the reset button. Okay, now I'm hitting the flash button. Okay, neither of those worked. So, well, this time I'm flashing thing we did before. No, here no. Flasher. It said to install, just double click. Oh, I need to give permission to open that. Give me a second. Open anyway. Okay, it's opening. Supposedly. Yeah, it's happening. So I hope it doesn't take that much time. I don't know. Right now, I feel like these haven't been so um, plug and play. I'm guessing there are alternatives. to this. I would like to explore them. So here, how to select. It's supposed to be this one. Notice you firmware. It's the one I downloaded. So downloads the floating binary. Open. The baud rate should be this one. The flash mode. I don't know. Erase flash. We'll say. Well. Oh, okay. Let's move to the flashing the firmware section for more details on this. To enable ISP32 firm flashing mode, bits must be pulled down before the device is set. If you have dev kit, you don't need to do anything as the USB connection can pull by a certain blah blah blah. Okay, I have the dev kit. I can. Okay, it's uploading the firmware right now, so supposedly nothing bad should happen. Still uploading. Hmm. Okay, I hope that that finished. Um, huh. Still uploading. So need to use this bulk rate. I think that's for sure. And apparently, just need to create the file and upload it directly. Which repo is this one? You done? Okay, I hope this is still working. Okay, I okay. This says This probably I would change that. No, it didn't make any change. I mean, something happens because this is bleeping because otherwise, why? Yeah, I'm thinking. Is that something about erasing the data? No, uploading stuff. Uploading stuff. We're missing like half of the scripts here. Um, else, let's see what else can do. Node Flasher, Node Firmware, DAppKit. This is history. The new board Node MCF. So, um, let's see, let's see. Um, thinking of right now, it's trying to connect it directly via USB to USB. So I probably will do that. I found a USB-C to USB-C cable, so uh, I can unplug this and connect it here again. I will allow. Uh, uh, uh. Okay, yo, I think we just need to wait for this to finish. The problem, it's taking a lot of time. So Let's see what else we can do. Yeah, that's insane. Maybe changing baud rate. Firmware successfully flash. Okay, if I change this baud rate, it takes a little bit more time, but still it has progress. Let's wait until this finishes, and after that we will see if we can upload now or file finally. Um, Come on, 10% more. 8, 9, 4. Done. Growth. Amazing. Unplug device to switch back to normal boot mode. Unplug. Okay, nice. Okay, has now the firmware installed. Okay, devices seems the same. Sudo. Well, I will do the same, but sudo. I'm curious about this, uh, but okay, at least we can type this. Just blah blah. What's that? Okay. Okay, that shouldn't affect them. TTY dot USB serial. Do you want to format the file system and delete idle files? Yes. Enable to establish connection. Why is that? Okay, let's node MCU tool enable to establish connection. Let's check. And remember, this is a two-part video because I knew we wouldn't have enough time uh, to keep exploring. But come tomorrow because I know we're about to end the session to see results. And I will, in the meantime, explore some more options. So I promise for tomorrow to have these already connected, either changing the board because I don't think it's blame of the board. I have to admit. I think there will be another turnaround for these that it's easier. The point is at the next section we will have in the beginning disconnected reading inputs and outputs, and the next session will be more for coding. In this one, we try to make a lot of connections and stuff in fully hardware. The next one will be full for coding and we are going to code the server and the web page that consumes the information from the device, right? Um, but don't worry, I will explain what I did to make this work, and well, that will be it. I will find why this does not make connection, and I will tell you on next section. So thanks a lot for joining me. I will remove myself from here and add myself back here. So remember, this was just part one. Come back for part two to discover the rest of the how to configure Node MCU and to make or to see the possibilities of making a great application that consumes the data and displays it real time in a dashboard, right? So I'll see you. Bye, and thanks for turning in here. See you.